So the main goal for lessons 1 and 2 is to get everybody on the same page and build up from the same foundation. Lessons 1 and 2 cover key core math concepts, and in this example, we're going to go over how to combine variables. All right, for 2x plus 3x, what we actually have to do is add the coefficients. Now, the coefficients is a fancy word for the numbers that are in front of a letter. All right, so 2x plus 3x, our coefficients are 2 and 3. We do have a plus sign, and so what we do is very straightforward. We simply add those coefficients. That will give us 5x. Notice I didn't change the exponent. We changed the exponents for multiplication and division. At the next example, we have 2x squared plus 3x. So in this case, we have the 2 and the 3 as our coefficients, but we have different exponents. Since these two variables have a different exponent, the 2x squared having a 2 for the exponent, the number up top, and the 3x having a 1 for the exponent. There is an invisible 1 there for the exponent. Since these exponents are different, we actually can't combine them. Our final answer would be 2x squared plus 3x. We simply cannot combine those. Now let's move on to multiplication. In multiplication, you actually multiply the coefficients, very straightforward. So that's going to give us 6x because we have 2 times 3. However, now, since we're multiplying, we do add the exponents. We have 2x, which means that there's an invisible exponent of 1. And then we have 3x, again, an exponent of 1. Now we have to add those. That will give us 1 plus 1 is 2. Our final result should have a 2 in the exponent. Moving on to the next example. Notice I did similar numbers, similar terms. We have 2x squared times 3x. Before, we weren't able to combine them when we were adding, but now we're multiplying. So now we can multiply the coefficients, and following the rules of combining variables, we are allowed to combine the exponents since we're multiplying. We have a 2, and then we do have an invisible 1. 2 plus 1 is 3, so we will have 6x to the third power. Moving on to division. We still divide the coefficients. Again, now we're dividing, very straightforward. That means you divide the big numbers, the numbers that are out in front. So 10 over 5, that is going to give us 2 over 1 when we simplify it. Now we may not need this 1 down below, but let's just show our work first. We have x to the second over x to the first. Don't forget there's an invisible exponent down there. 2 minus 1 is 1. So up top we have x to the first power. Again, I did 2 minus 1. So when we're dividing the variables, the exponents are actually subtracted. It's the opposite of multiplication. Moving on to the next example. 24 over 14. That's going to simplify to 12 over 7. Looking at the variables, we can subtract the exponents. Again, they're both x. They're both the letter x. Therefore, we're allowed to do this. If we had x to the fifth over y to the second, we're actually not allowed to subtract the exponents, but again, we go more in depth during the lesson. 5 minus 2 is 3, therefore our final answer is going to be 12x to the third over 7. 15x to the second over 3x to the eighth. This is the last example here. In this case, the larger exponent is down below. That confuses students sometimes, but here's a simple solution. First, let's focus on the coefficients. Let's get those knocked out right away. So we have 5 over 1. Focusing on the x variables and the exponents that are attached to them, we could do 8 minus 2 as long as we put the exponent down below. So for example, 8 minus 2 is 6, but we're not going to put x to the 6 up top. That's what we're not going to do. We're not doing that. Because the larger exponent is down below, let's go ahead and keep that variable down below. I put x to the 6th down here. There we go. To finalize that answer, we'll have 5 over x to the 6th.